Our enthusiasm for recreation and sports over thousands of years has led to the creation of some of our grandest and most impressive buildings.
In this program, we visit one of the finest Victorian garden buildings, the Tropical Palm House at Kew in London. Travel to Italy to the futuristic vision of the San Nicola football stadium in Bari. But we begin here at the magnificent Roman amphitheatre in Verona. The arena is the mightiest of Verona's Roman monuments. Dating from the 1st century AD, it survives in remarkable condition, thanks mainly to the deliberate policy of preservation, which began in the 13th century. It's in such good condition that it's still in regular use today, particularly during the opera season in the summer.
The arena's original capacity of some 30,000 people gives an idea of the importance of the town and its amphitheatre in Roman times. The arena stood outside the ancient Roman walls, and these are the remains of the main ceremonial entrance facing the town. On the opposite side, you can see the gate leading to the country through which the dead and wounded were taken away. Walking into this fantastic space is an extraordinary experience. The amphitheatre is now at the centre of modern Verona, but all that's invisible from here. It's as if we've been transported back to ancient Rome.
The great rows of seats rest on a complex system of vaults and pillars which run right around the inside of the structure. Tall passageways allow people to circulate. Although much of the amphitheatre has been preserved, only a fragment of an original outer wall remains, standing sheer above the neighbouring streets.
In Roman times, the arena hosted all sorts of spectacles. There would be gladiatorial fights, boxing matches, baiting of wild animals. This drop separated the people in the lower seats from the action in the arena.
The original stone on the exterior and on the terraces is a limestone quarried from local hills and cut on site during construction. It's worn now, but still looks beautiful with pink and white colouring and a soft texture. The huge rows of stone terracing are extremely heavy, and supporting them was a great challenge for the Romans.
Under the seats, there are vaults made from concrete, Roman concrete, with a stone facing. This is some of the exposed concrete up here. It's strong in compression, so it's ideal for carrying the weight of the seats above, but it cracks easily in tension when it's pulled apart. So to bridge across the passageways, the roof is vaulted with arches, which spread the weight to either side.
The traditional Roman arch is semicircular. It would have been built up on wooden scaffolding, which was then knocked away from underneath. But there are other ways of bridging spaces.
Sometimes they used a stone lintel instead across the doorway, like this huge one here. It must weigh over 4 tons. It works like a beam sitting on pillars on each side of the door. It looks as though it's carrying a huge amount of weight. But here on the other side, you can see the trick. Up there is another round arch, which carries the weight of the roof and lightens the load on the stone lintel. So it only has to carry its own weight and the weight of the bit of wall above it.
At first glance, this one looks the same. But then you notice there's a wedge-shaped stone in the middle.
It's a special sort of arch called a flat arch, and it's almost unbreakable. The 3 stones work like these 3 boxes between my fingers. When you push down on the middle, the arch pushes outwards at the ends, and you can really feel it in your fingers. It works as long as the ends of the arch can't move. Otherwise, it just falls through. These great extensions at the end mean that it's really firmly bedded into the wall and it can't move at all. And the wedge-shaped design is clever because even if the middle drops a little, it still works as an arch and it's perfectly safe.
The great walls supporting the high vaults are made of concrete with a stone facing. At the ends of the walls, these pillars are cut stone, partly for style, but they also provide support for the outward forces of the arches.
There was an outer wall which ran right around the amphitheatre, but now only this section on the left with 4 arches remains. It looks very precarious, but it's been strengthened with steel bars which run right down from top to bottom, pulling down on the wall and holding it firmly in place. That was done in the 1950s. They're now thinking of replacing the steel bars and rebuilding the arch on the second level, like this. This will give people a much better idea of the original structure of the amphitheatre.
Following the Roman period, stone was stripped from the walls for other buildings, and in the 12th century, earthquakes caused major structural damage to the arches. But from the 13th century, efforts have been made to replace the stones. A major restoration is now underway again to preserve the vaults and external stonework. It will ensure that we can safely hand on to future generations this remarkable survivor of an age where much of mass entertainment was a violent and gory spectacle.
After the fall of the Roman Empire, the building of such great public arenas died out completely. But centuries later, new forms of recreation emerged, which also required special buildings, although for a rather more genteel purpose, as we shall see next.
The Palm House in London's Kew Gardens represents the classic values of Victorian Britain in an age of unprecedented discovery. The British Empire was reaching out to the furthest corners of the globe and bringing treasures of the world home for an increasingly curious public to enjoy. Amongst these wonders were the exotic plants of the tropics. Entirely made from wrought iron and glass, the Palm House is the first building of its kind in the world and is the largest curvilinear glass house still standing.
Just glancing at the Palm House, 2 features strike you immediately. It's very light in appearance and it's formed almost entirely from curved surfaces. Its shape was partly for aesthetic reasons, but principally because horticulturists of the day were convinced that curved glass was best for light.
It was designed and built by the special partnership of the architect Decimus Burton and the engineer Richard Turner in 1847. Their task was to create a building which would provide sufficient light and heat for tropical plants, but also allow free access to the general public. The hardest challenge of all was to create the largest possible open, uninterrupted space where the tallest of palm trees could thrive.
Turner's expert knowledge of the production of iron was the key to their success. Burton had planned to use cast iron for the frame, but Turner's innovation was to use wrought iron ribs called deck beams, a type of beam normally used by shipbuilders. In fact, the ribs of the Palm House work very much like the hull of a ship, only upside down.
It was a great piece of lateral thinking to adopt shipbuilding ideas for the construction of the glasshouse. Thanks to Turner's brilliance, the Palm House was one of the most innovative structures of its day.
This main rib reaching up is one of Turner's deck beams. The arched ribs carry the weight of the roof away from the centre and down to the foundations. And from here to the top, it's made of a single piece of iron. The downward force tries to bend the arch outwards in the middle, just like I can do with this cane. So it has to have sufficient strength in bending, what we call tensile strength, to stop it from snapping. The ribs of the main span sit on top of a row of columns on each side of the hall, like these. The columns also support a gallery at the top for viewing the trees.
Not only is the gallery useful for maintaining the palms, but it also provided the Victorians with an experience far removed from their everyday lives.
Up on the gallery, we can really appreciate how much space there is. You can imagine how people must have felt leaving the grime of Victorian London and finding themselves face to face with a tropical jungle. Burton's original design required additional columns in the central area of the hall. This was because the traditional cast iron ribs didn't have enough strength to span across the whole width needed for the plants. Turner's wrought iron solution allowed for a single span right across the hall without any additional support, removing the need for the additional columns and leaving the space for the trees. Here we can really see the advantages of wrought iron. This capital is bringing the weight of the roof down onto the rib here. If it was cast iron, there'd have to be a column all the way to the ground, right here. The Palm House was one of a series of controversial iron and glass buildings of the day. These structures were not so much built as assembled, using entirely prefabricated components, foreshadowing construction methods often used today.
Another unique feature of the Palm House is the sheer quantity of glass. What had once been a luxury, expensive material was now available in large sheets at low cost, thanks to the 1845 repeal of excise duty on glass. Turner was one of the first engineers to capitalize on this. The Palm House has continued to provide an invaluable resource for scientific study. As a building, it stands as testimony to a pioneering era of new materials and new methods, at a time when Britain was keen to share her preeminence in engineering with the public.
But this was just the beginning of the new age of leisure, an age which would see its clearest expression in the 20th century in the rediscovery of the sports stadium.
This is the San Nicola football stadium in Bari, southern Italy. Built for the 1990 World Cup finals, it holds 58,000 people, all seated. It was designed by the renowned Italian architect Renzo Piano, who wanted the stadium to look otherworldly, like a spaceship that had just landed, or as he described it, a shell suspended in the midst of greenery. It's part of a vast park in West Bari, and there are plans for it to be turned into a sports city. The stadium houses the local football team and also an athletics track.
My immediate impression is of a building which is almost floating, only lightly touching the earth, It's a stunning sight, a perfect combination of architecture and engineering. It's beautiful, and for a 60,000-seater stadium, it feels very compact. What we're seeing here is just the upper stand. There's another whole stand below, hidden by this landscaped hill. In fact, the pitch is 2 meters below ground level. So while the visual impact of the stadium's sheer size is reduced, it serves only to enhance the curves of the canopy and the upper stand.
The great bowl of the upper stadium sits on stilt-like columns underneath. But inside the structure, running inside the perimeter and cleverly hidden from view, is a concrete ring beam holding the whole stadium together. Resembling an open flower, the shell of the upper stand is clearly divided into sections, 26 in all. Each section is separated by a distinctive vertical slot which provides access to the seating and also provides a glimpse inside the stadium from outside. Each single bay, then, is like the petal of an open flower, giving Bari Stadium its unique appearance.
It's a very exciting structure. At Kew there was a feeling of serenity, even study, but here it's all action. On the pitch you can almost hear the roar of the crowds. The colours in the stand and the light fabric roof all combine to give it a real buzz.
You can see the upper stand clearly suspended over the lower seats. The seating blocks are all precast concrete units fitted onto the shell beneath. Using a combination of prefabricated units and concrete poured in situ, the contractor minimized the cost of construction.
We're underneath the seating of the upper stand, and this is where the ring beam runs around the perimeter inside the great curved shell. It connects these supporting pillars and holds the whole upper structure in place.
The angle of viewing for spectators is very important. They must obviously be able to see over each other's heads. Ideally, the stand would be curved all the way up, but for simplicity, the upper stand is made up of 3 straight sections that get steeper towards the back.
The layout of the stadium is meticulously thought out. No spectator should be more than 190 meters from the football pitch, so that defines the extremities. The most popular place to sit is in the middle on the side, so there are more rows of seats there than at the ends. And finally, the VIPs and the television cameras are always on this side of the stadium, looking east, so that for afternoon games, they have the sun behind them.
Up at the back of the stand, the great steel supports for the fabric canopy arch out over the seating. They're braced against swaying in the wind by the white truss that runs along the top at the end of the arms.
The canopy is a coated glass fibre fabric stretched over the thin arched beams which span from here to the truss at the top. It provides some protection from the weather, and being convex, it adds to the design architecturally by completing the curve of the upper stand below.
Being a membrane rather than a solid roof, it's much lighter in weight. It also lets some light through, reducing the amount of floodlighting needed and adding to its attraction at night when the whole stadium is lit up like a lantern.
just climbing up over the roof. It's extremely windy because the curved shape of the canopy directs the wind right over the top. And here we are, right at the lip of the roof itself. You can see the floodlights fixed all around the perimeter to illuminate the ground down there. It's a spectacular view. Perhaps this is the best seat in the house. Since the 80s, public safety has become a major concern at football stadia. The first response was to make them all-seater so that crowds on the terraces aren't crushed. Secondly, separation of spectators, both from the pitch and from each other, is a key feature. The Bari Stadium has a moat all the way around the pitch, as well as these dividing walls in the stands. Sad, but necessary.
But the most important safety aspect of a modern stadium is how quickly it can be evacuated. This has to be carefully designed. At Bari, each of the 26 petals has its own exit, and the entire stadium can be evacuated in 5 minutes. The Bari Stadium is a distinctive landmark. The boldness of its design is matched by the skill of its engineering, which has enabled the idea of this floating stadium to become a reality.
The amphitheatre at Verona, the Palm House at Kew, and the stadium here are all buildings that evoke a sense of occasion that perfectly complements what happens within. The buildings are very different, but their purpose is the same: to create an exciting space for entertainment and spectacle. And exciting buildings means exciting engineering.
In our next program, we look at the structure of towers. We start with the medieval towers of San Gimignano in Italy, travel to England to the remarkable Liver building in Liverpool, and scale Europe's tallest office building, the Commerzbank in Frankfurt, Germany.